Hello everyone, my name is Timothy Lee Grant, and today we are starting a new topic of focus, which is binary search. So my strategy for LeetCoding is to pick one topic, one algorithm, focus on it, learn it, learn it, learn it, get good at it, and then move on to a different topic. But then you have to revisit the old ones that you've done, right? So don't forget completely about the old ones, but focus on a topic, move to a different topic, move to a different topic. This is going to be our new topic, which is binary search. So we are going to continue to do binary search until we're able to solve mediums relatively easy. So we did it for depth first search. Now let's do it for binary search. So let's start with an easy. So I am going to minimize myself here. What's that one? That one up there is a hard. Not going to do that. Okay, square root of x. How does that one sound? Let's do this one. All right. So, did I already attempt it? Hold on. Let me try to do this like thing so I don't see what I tried. I guess I already attempted it. Maybe I didn't solve it. Okay. I can't remember doing this one, but we'll see. So, square root of x. Given a non-negative integer. So let's see if I can do it this time. All right, given a non-negative integer x. So x is going to be non-negative. Return the square root of x, rounded down to the nearest integer. Okay. So we're given a non-negative number and we need to output what the square root of it would be. Okay. The return integer should be non-negative as well, which makes sense because the square root is never negative. So you must not use any built-in exponential function or operators. So we can't do like power, which if you want to take the square root, you can just do like the 1/2 power, that's the square root. Or we can't use this double ding ding, which is like squared. Okay, so all right, that I guess is the problem. How do we actually go about solving this? So we're in binary search. So how would a binary search be applied in this scenario? So if I have a number, let's say 10, okay. Can I okay, so what does it mean to be squared? It means that number multiplied by itself like that many times, right? So like 10 squared is 10 times 10, okay? 10 cubed is 10 times 10 times 10, okay? So a number squared is just it times itself. So the square root is asking what number times itself is equal to that number. So if I have 10, I'm asking what number times itself is equal to 10. Okay, so that's the fundamental question that I'm asking for square root. How do I apply that here? I think what I can do, so I can start. Okay, so let's take the number 100. Okay, that's the number that's going to be x. That's what's coming in. And now I want to ask the question, what number times itself equals 100? Okay, now we can start off this search. It's going to be somewhere between 0 and 100. And now I can search in the middle. So this is how binary search. So I look at the middle and I say, okay, 50 times 50, is that greater than or less than 100? If it's greater than, then I need to search the lower numbers, right? I say that's too big. I haven't reached, or I need to decrease my numbers so that I'm able to hit my target of 100, not like 25,000, is that? Um, so then I can go to 20. So from 50, I then go to 25. 25 times 25. Okay, is that bigger or smaller? That's too big. Then I go to half of that, and then eventually I settle on 10. And I say 10 times 10. Is that greater than or less than 100? It's equal to. Therefore, that 10 is the answer. So the fundamental question that I'm asking is what number times itself? Yeah, I think this will work. So I'm just trying. Okay. When I first saw the problem, I was like, I have no idea how binary search is going to be applied in this situation. But luckily I was able. I think so. One thing with this channel is I'm trying to not just show that I solved this problem or that problem, but also kind of to document my thought process and how I'm moving through these problems. And so I guess a note to myself and a note to everyone else that's watching. Like, okay, so I guess I feel like that was a good method for trying to see a problem that you can't really immediately understand. I tried to ask, what was the, let's see, so how exactly did I do that? I said that I looked at the definition of what squared was, and then I was trying to find out what the definition of square root was and what the fundamental question which was being asked. And once I understood what square root actually meant, instead of just a button on your calculator, or I knew that, okay, to the 1/2 power is the same thing as square root. But once I kind of targeted in on what square root actually means, then I was able to then try to think of the algorithm that might lend itself to completing this objective. Okay, so moving forward in future problems, I'm going to, if I encounter a problem that I don't understand, try to figure out what is it fundamentally asking. Okay. So anyways, now to actually implement this. So I am going to, let's see, so left equals 0, right equals length of x. So I'm starting the range between 0 and x, so 100. No, x is an integer, so this is not a list. Those would just be x. Okay. Now what do I want to do? I want to do while left is less than, and I'm going to suspiciously say equal to right. So I am not quite sure. I'm not convinced with this equal sign. We're going to have to think about that. I'm not sure. So what do I want to do? I want to say, and then current equals left plus right, and then integer division by 2. So 2. Okay? So this is just the midway point. So if current times current is greater than what? X. Then what do we want to do? Okay. If current times current is greater than X, that means that we need to look in the smaller range. Correct? Okay, so that means this means that I need to change the right-hand side equals what? Equals equals current. So I want to change right to be, so here's 0. Here's 0, here's the top, here's current. So I want to say, okay, so current is too big. I need to search this space between current and 0. But I already said that current is too big, so can I do current minus 1? I think I should be able to. Current minus 1. Okay, so now, else if current times current is greater than, or is less than X, then I want to change right, or so I want to change left. So left equals current. So I'm here, current is in the middle. I change current, but I already checked current, so I can do current plus 1. Okay. Else if current times current is equal to X, this is the case that we return current. Okay. So in this case we return. Now, is there any situation in which we run into an infinite while loop? So this right is always decreasing, and this left is always increasing. Okay, so eventually, and it has to be one of these three. So one of these three has to hit each iteration. If this one ever hits, we're done. If this iteration hits, then right decreases. If this iteration hits, left increases, and eventually we get to this point. Now, we need to return something. So because we're not always guaranteed to actually find to always hit this case. So like for example, if this x here, if x is 101, this current is never going to, no matter what I do, I'm not going to hit the 101. So I need to, because it has to be an integer value. So the square root of 8 is this, whatever, 2.828. Since we round down to the nearest integer, 2 is returned. So how do I take into account that fact? Can I just do this right here? I'm not sure if I can. Let me see if this works, and if it does, then I'll spend more mental energy actually trying to analyze it. I'm not sure if it will. No, it doesn't. Elif. Okay, so let's see if this works. Okay, so it did work. Now it's time to actually analyze kind of why that worked. So once I finish this while loop, I am going to have left and right preserve the last state that they were at. I know that this integer division does return the rounded down version, so that conforms to what the problem says. Okay. I'm also curious if I just did, oh, but this is left plus 1. So, okay. I always get off on these like -1s, +1s, and trying to wrap my head around each iteration, how it's happening. So like if I have 10, x is 10, okay, I have 0 and 10, okay, then I do 0 plus 10 divided by 2, so I have 5 now, current is 5. I say 5 times 5 is 25. That is greater than 10. So right is now equal to current, which was 5, minus 1. So 4. Okay. So then we do the same thing over again. I come up here. So 0 plus 4 is going to equal 2 here. So current is 2. Now 2 times 2 is 4. Is that, and that is not greater than 10. Okay. So it's less than 10. So now left is current, which is, we said 2, plus 1, 2, 3. Okay. So now 3 plus, what did I say, 4? 3 plus 4, I think, is, and then divided by 2. So 7 divided by 2. Okay, so that is 3. So we're rounding down, 3.5, 3. So current is 3. 3 times 3, 9. It's less than. So that doesn't hit. This does hit. Left is now going to be 4. Okay. And then I want to check left and right are both 4, right? I think. So I want to check 4, see if it's valid. So that's why we do need the equal sign. So this is 4 plus 4 is 8. Okay, divided by 2 is, it says 8, and then divided by 2, 4. Okay. 4 times 4 is 16. It's too much. It's too big, so I take right, and now right is 3. So right is 3, left is 4. We don't do this. Right is 3, left is 4. So we still have that 7, and now this is 3. So we return 3, which is 9, which is the lowest, like, the lowest middle. Lowest middle, that's not the correct way to say it. It's like the closest whole number that we could have arrived at. So I passed the test, but to be completely honest, I still feel like I kind of got lucky with that problem because I wasn't quite sure about this one, and I didn't fully kind of comprehend how to do this. So we absolutely need more practice on depth first search binary search, and luckily there seems to be a lot of problems here that we have that we can work on this topic. So if that is interesting to you guys, please subscribe to this channel. That would be amazing. I just hit 100 subscribers. I'm so happy. Thank you, everyone. And yeah, so we will continue on this binary search journey. So thank you for watching. My name is Timothy Lee Grant, and I will see you tomorrow.